Welcome back to Workshop Wasteland Tricks or Treats, day number 16. Last week we talked a little bit about 3D printing, and I showed you how I cleaned the build plate on my 3D printer. And today I want to show you how you can take about 77 cents worth of plastic and utilize it as a prototype for a part that you want to make out of metal to ensure that it's going to work before you make it out of metal. So I'm going to do my best to give a screen record with my camera on my computer. I know that's not the world's best way to do this, but I've not successfully used a screen recorder that uploaded a nice video. It was always real crappy quality. So if any of you have an awesome screen recorder so that I could in the future use it for videos like this, please down in the comments down there, let me know what it is. I'd love to find something that works really well. Otherwise, hopefully you enjoy this video. Please don't forget to subscribe and check this out. I think it turned out fantastic. Alright, so again, sorry for the kind of crappy quality that this is going to be, but it's sort of the best that I can do. So I needed to mount a NEMA 23 stepper motor, and I found this mount on Tinkercad for a free download. The person's name is Sailorman33, but I didn't need this extra piece right here. As you can see, this is kind of an odd piece sticking out of a stepper motor mount. However, it has the nuts and bolts that we need, or the basis that we need for the stepper motor. So then I came over to Tinkercad, and as you can see, I cut off that silly piece and added this onto the side in Tinkercad, and turned out really well. It was exactly what we needed, and you know, there's not a lot to this. Tinkercad's really basic and it's free and it has a lot of the same features as Fusion 360 does, but definitely it's basic CAD software. However, it was good enough to get done what we needed to get done. So you're probably asking yourself, what on earth is this for? Well, check this out. I think this is pretty sweet. In the past, what I did was took my rotary table and fitted a stepper motor onto it. That way you could very accurately index the rotary table. And it works really good. However, if you need to go back and forth, there's too much backlash between the gear of the table and the worm gear of, I guess let's call this the spindle. And because of that, I'm able to move this about, without anything moving, I can get about 6 degrees out of this. So that's 6 degrees that's just going to compound a problem over and over and over and over and over again. And it's really hard to work through that. This does work good if you go in the same direction. I've successfully cut gears with this, and I've indexed a few other parts, and all was well. However, I thought, man, there's got to be a better way. So I believe it was My Little Tony on YouTube took one of these 5C Call-It spin indexers and put a stepper motor on it. So this aluminum piece is the piece that we 3D printed. So this is that piece back there. I drilled and tapped. I ended up going with only 3 holes. 4 seemed a bit extreme. I mean, it's a 1/2 inch thick piece of aluminum, so I think it's going to work just fine. But as you can see, stepper motor's mounted. It's bolted onto the spin indexer, and then this is going to be able to rotate without any or very little backlash, because it's more of a direct drive now. So that's going to spin the spin indexer, which of course up front houses 5C Call-Its that you'll have your piece in, and it's going to work hopefully really well. So like I said, this rotary table setup worked fine, but what I really hated is if I wanted to use my rotary table as its intended purpose as a rotary table, then this dang stepper motor was always on here. So now primarily I'm going to use this for gear cutting, but now this can just stay this way, and it's also a lot easier to take this off than it is to take this stepper motor off and put the handle back onto my table. So I think this is going to work better in the long run. And then just to show you, this is the controller that I built. This is based off of an Arduino Uno, and there are free sketch to download that you make some changes to. Once I get this up and running, I have to change my gear ratio around and all of that, because this is different than what the gear ratio of this rotary table was. Once I get this up and running, I will show you how this all works. It's probably not going to be a tricks or treats video, only because I don't want to beat this to death in the same little series, but that's got a connector to plug into it, and then you feed it with 24 volts DC down there, and you use the keypad to do a lot of different features, and we'll show you all of that in a video in the very near future. So that's it. That's this tricks or treats video. I just wanted to kind of highlight the simplicity of using a plastic piece that you 3D printed to use it as a prototype piece, you know, before you waste metal. Like I said, this is literally like 77 cents worth of plastic. It's got 2 walls, 1 top and 1 bottom layer, and like 5% lightning infill. So it's not strong at all. It's surprisingly strong considering how thin it is, but it was literally only to see if this proof of concept and the idea that I had in my head was going to work to bring this all together. So don't look past 3D printing for prototyping. You know, it doesn't have to be your final piece, and it doesn't have to be something that you're going to use, albeit I do have a ton of stuff that's 3D printed. In fact, this gear right here is 3D printed, and it's going to work, I think, perfect, because it's only driving a spindle, which doesn't take much. So I just wanted to highlight the importance of, or the simplicity of, using that to prototype parts. And then here it is. You know, you can take all of your measurements that you need right off of this piece, transfer that onto this piece of aluminum, in my case, and machine that part, and voila. I'm totally confident, had you printed this stronger, say like 6 or 8 walls, maybe 4 or 5 top and bottom layers, and 20% infill, this was strong enough for what you're asking it to do here. But I have the milling machine, I had the aluminum, why not make it more of a permanent solution? So, as always, thanks so much for tuning in. We'll catch you in the next video, which will be tomorrow.